everyone, and welcome to today's webinar, How a Well-Designed Automation System Can Contribute to Increased Yield and Quality. I'm Kate Spurgeon, editor of Greenhouse Management Magazine, and I'm so glad that you could join us. Today, we're going to hear from the expert team at Argus Controls about the importance of environmental control systems, why they're crucial for the collection of useful data, and an important labor-saving tool, and how well-designed systems can bring your operation to optimal levels. So just a few notes before we get started. If you have any questions at all during the discussion, please go ahead and enter them into the chat box, and we're going to get to as many as we can at the end during the special Q&A session. So please, throughout the presentation, feel free to enter those, and we'll ask the team at the end. Also, please note that a recording of the conference will be available in a couple of days. So anyone who registered is going to get a link to the recording via email. And also at the end of today's discussion, we're going to have a very short survey that we'd like you to participate in. So please don't forget to fill that out. And then I'd like to go ahead and we'll get started with introductions of the panel here. So first up, we have Eric Schmidt. Eric is the inside sales manager at Argus Controls, where he manages a team of estimators for providing automation solutions for controlled environment agriculture projects in the commercial, institutional, research, biotech, and cannabis sectors, both nationwide and globally. Eric has been with Argus for over 28 years, enthusiastically assisting clients with control system design, layouts, and equipment control applications for their horticultural projects, as well as preparing budgets and bid proposals. So Eric leads the Argus Inside sales team in assisting with delivering quality project proposals to their clients. Also joining us is Rico Gary. Rico is the key account manager for Argus Controls, and he has 3 years of experience with Argus and has been in the horticultural industry for about 6 years. Rico started his career at Argus Business Development in the Midwest and now manages companies who sell Argus across North America. And also joining us today is Justin Jacobs. Justin is the key account technical manager at Argus and has been since 2018. As part of his role, he travels to different sites all over North America and has been working with Argus and Coviron equipment for the past 6 years. Justin has more than 20 years of low voltage controls experience. And in addition, he has 6 years of horticultural research experience and 20 plus years of agricultural livestock management experience. So welcome, everyone.
Thank you.
Thanks for having us.
Absolutely. So to start us off, can you start by telling us a little bit about what a well-designed automation system is?
Yeah, I'd be happy to kick that one off. So a well-designed automation system, first and foremost, is going to be a fully integrated system. And what I mean by a fully integrated system is that there are all of these things that affect the that affect your greenhouse and affect the yield of your crop. Different watering systems, fertilizer systems, lighting systems, venting systems, heating, cooling, all of that, right? So the more of that you have under one platform, the better suited that you're going to be as far as full automation, because you have essentially every piece of the puzzle underneath one platform. You know how equipment is affecting each of those different dynamics within the greenhouse. And then you have a macro and micro view of what that looks like, from this is what my horticultural facility is doing to this is what the equipment and mechanical systems within a specific zone are doing. And then all of that is constantly collecting data, because data-driven results is really what I think is very important with a well-designed automation system.
Exactly. Having the data there, knowing what all the pieces of equipment are doing and integrated together, you can, having pre-programmed parameters to know that they're all operating within their pre-designed set points and operating conditions help you to be able to just focus on the things that aren't working within that dead band. So it really helps you optimize your time you're spent so you can spend more time with the crop.
Yeah, and I'd have to agree with that, Eric and Rico. And it gets down to a finite point, like lighting levels, very tight temperature control ability, very tight RH controllability, because when you're talking about increasing your yield or quality, these factors are the most important, right? So if when you talk about a well-designed automation system, that's going to be, like you said, Rico, a totally integrated system, and knowing how to control that equipment to a point to be able to get that really fine tune on your temperature control, for example, to where if you have the proper equipment, whether it be vertical farming for vegetables or greenhouse controls to grow root crops, uh, you might be able to get that down to plus or minus 1 degree or 2 degrees off your set point, which if you've got that kind of control, you're also going to be able to hopefully control RH on top of that if you have the right equipment in place, because ultimately you're really chasing that certain cultivar's optimal environmental needs, which varies from cultivar to cultivar. So if you want to chase a certain VPD, if you don't have a good control system and your equipment isn't well designed around that control system, then you're going to have a hard time, like for example, preventing powdery mildew in your crop, which can be very detrimental. Or there's a host of other things that other pathogens that might affect your crop, mostly because if you're putting a lot of stress on those plants, you're making them susceptible. So if you're just going to have a control system that doesn't really do much, maybe opens and closes, say some ridge vents, and it doesn't really go off of any kind of real deep parameters like VPD, or you're trying to prevent that environment from ever getting near the dew point, you're just going to have a hard time controlling that.
I think what you've talked about there, Justin, too, really explains the concept of flexibility within controls. A well-designed automation system is going to be very, very flexible because, to your point, you're never going to know what your mechanical design is really like until it is automated, because, the control system is normally the first thing to figure out how the mechanical system is really going to operate. And, you do the best with the equipment that you have. And then you also have the environmental conditions that you have to deal with as well. So having the flexibility to be able to tune the equipment and the mechanical systems based on weather conditions, or even based on a piece of equipment failing is super, super important.
Yeah, and that kind of goes back to, let's take a greenhouse, for example, again. If you have a well-designed control system, you could actually be measuring your outside temperature to where if you're actually taking that air in, you're knowing what kind of air, what the temp is, what the RH is, and then you're starting to look at psychrometrics and saying, hey, if we take that air at that temperature and that RH, what do we have to do to our equipment, or what temp when we want to draw that up to our set point temperature? What's the RH going to do naturally through psychrometrics? Now, what kind of equipment do we need to utilize, heaters and whatnot, to bring that down to not only our temp set point, but also our RH set point? So a lot of decisions are just getting made, and we can completely automate that just to the control system, to where no one's actually having to make these calculations. It's already programmed in, and it's making these decisions for you. That's a really big deal, because then that, hey, depending on the temperature and RH outside, my equipment's going to take care of my crop.
Yeah, having predictive algorithms is definitely an advantage of a high-end control system, where it is able to consider outdoor climate conditions and pre-plan what you need, where you need to be with your equipment, rather than you having to personally figure out when I want to turn it on or have it come on too early or too late. having that predictive algorithm in there allows for the environment to not have a hiccup and try to follow set points as close as possible and keep that environment optimum all the way along.
Great. So can you guys talk a little bit about the macro and micro views and conditions to kind of understand what's happening in your greenhouse, whether it's the entire greenhouse or just one specific zone?
Yeah, so when you talk about macro and micro views, one of the advantages of a truly fully integrated control system is that you have the knowledge of what's going on throughout the entire facility. And what a well designed control system or automation system will do is it will give you a very good view of this is what's going on at my entire horticultural facility. And then you should be able to dive a little bit deeper or go a little bit more micro. I want to know what's going on specifically in this zone. Okay, so I click here and now I can see what is going on in this zone. And usually when you're looking at that zone view, now you're taking a look at not only environmental parameters, but you're also comparing them against external parameters, like for example, your weather station. And then you're also taking a look at what that equipment is actually doing, because part of what you do with automation systems and control strategies in general is you try to optimize the way that you utilize your equipment and mechanical systems. So, and usually the way that you try to optimize those is based upon what equipment is going to cost you the least amount of money to use. Is kind of is normally a good place to start. And then you take a look at, and the best way to really decide that is to understand first what's going on outside, and then taking a look at the equipment that you have within a zone and trying to create some strategies around how you can use that efficiently. Because obviously one of the benefits if we're talking about greenhouses specifically is that you get to utilize those outdoor conditions, whether it be through your solar gain of the greenhouse or through air exchange, bringing in outside air. There's a lot of different things that you can do, and having that macro view of this is what the facility is doing and that micro view of that's what this zone is doing to even a more specific view of this is what this equipment is doing is very, very crucial to a well-designed automation system.
Yeah, I'd have to agree with that, Rico. Even to the point of if you have a good automation system in place, you can add a lot of sensors to it and actually started identifying even microclimates within your zones to where you can make decisions around either needing to add equipment or maybe you need to add some heaters, or maybe you need to add some half fans to get better air circulation to try to homogenize that environment. But, if you don't have all that equipment in place and have a good automation system that can integrate all those sensors, you're kind of guessing a little bit, especially if you've got some very large zones in a mostly greenhouses. Vertical farming indoors tends to be a bit smaller just because of the real estate. But in greenhouses, you can make some big decisions, and people have made equipment changes because they're all of a sudden, because they're able to graph this and document it, and then now they can justify, hey, we should add this equipment, and here's why. We've got some very large microclimates in our environment. Here's the graphing, here's the report, here's all the sensor data, and to make these educated guesses. And without a well-designed automation system, you just can't make these decisions. You're guessing, right? Where this is actual proof, almost scientific proof that, hey, this is going on in my environment, and this might be some of the reasons why, we have certain good yields during certain seasons. Maybe our shoulder seasons are very comparable, but we can have some obvious reasons why in winter we're getting less yield in the summertime, light levels and all that, to where you can make these decisions saying, hey, we could probably increase our yield, our productivity, and even our quality if we add this climate, because now we're all of a sudden recognizing that, hey, we've got these microclimates in our greenhouse, or you know, maybe we should spend the money to add a little bit more equipment. And here's why: because our graphing, now we're graphing our temperature and our humidity, and we can take all that data, compile it, and justify the purchase of those resources.
It allows you to see cause and effect, which is a really fun thing that's super important when you have data-driven results. You know, you can make a decision within your greenhouse or your growing environment, whether it's an equipment selection, a different control strategy, whatever it is that you're doing, and you can actually graph and see what the result was. So complete cause and effect.
Yeah, even before you have to wait for impact on the plants, because usually by then it's a little bit of a harder way to get back.
Too late at that point.
Yeah, and I totally agree with that. That you know, even like lighting levels, and Enrico, before you're talking about maybe the most efficient way to cool the room is maybe drawing a light shade curtain across. Well, you can also make those decisions if you have the right sensors in place, saying, no, I want to keep the fans on if the light level is only at this certain level, and keep that shade curtain open. But if I got a really good sunny day, yes, I could, and it's fairly cool out. You know, it's not cooking the place. I can just utilize my shade curtain to help cool, and then I can keep my fans off. You know, doesn't seem like much if you've got 3 or 4 zones, but all of a sudden you got 50, 60 zones in one area, and you have your fans off for most of the day. That's a significant savings in electricity. So, and again, this is increasing your profit on your yields. That's a whole nother aspect of increasing yield and quality. Not only are you doing that, you're also buffering your profit margin because of these decisions made by your automation system.
The cost is super crucial. I mean, yeah, you can increase your yield or your quality, but if it costs you, you know, substantially more money to do it, then are you really ahead at the end of the day? And the answer is probably not. So you've really got to make that balance and understand, you know, to your point, you know, talking about that struggle between, you know, what do I want? Do I really want all this light, or do I want to, you know, keep the place at a decent temperature level? And then what is your give and take there? And that's super crucial, especially in a greenhouse. And an indoor growing environment, you don't necessarily have those challenges because everything is more insulated. A lot of the times you have preconditioned air that's coming into a space, so you can hold a little bit tighter parameters, but in a greenhouse space especially. And then even, you know, getting back to your concept of cost, you know, you've got your best friend, which is the sun, right? You talk about something that's real expensive. Well, kicking on supplemental lighting is very expensive. If we can avoid doing that through some type of you know, like for example, with the Argus system, you'd utilize the DLI program to be able to make that decision. We've had several customers that have saved lots of money utilizing that.
Yeah, and it's a pretty smart program, right? So that the DLI program, it takes into consideration the amount of light that you're that's in your area and what you anticipate to get for the day. And knowing how much your crop needs, you can manage your actual grow lights just to be able to provide that extra amount, not overshooting, not spending, you know, not having them on for hours on end just because it was on a timer. So it's really a way to feed back into that bottom line.
And just to add to that, Eric, you know, even if you don't use DLI, having a good automation system, like you said, is very flexible. So if you don't use DLI, say you want a 14 or 16 hour day, but if the sun is intense enough to meet a certain threshold, say you want 400 micromoles or 500 micromoles, you can actually tell those lights to turn off at that point.
Right. Yeah.
But you can still keep your entire photo period duration, you know, because then the lights in the evenings or early morning are going to kick on. But as soon as that sun comes up and you meet that threshold, that automation system is going to tell those lights to come off. So again, adds another efficiency to the overall grow.
Exactly. Yeah.
The one thing, you know, just transitioning, we've been talking about environment. quite a bit here, which everything kind of ties in, but you know, our irrigation system, automating your irrigation system is huge, because you can, again, being versatile, and having a well-designed system, because irrigation, you have to put a lot of thought into that, right? You know, how many feed valves are you going to have? And we're tying into irrigation automation, or nutrient delivery automation. So how many feed valves, how many branch valves, are we going on to benches? Are we doing flood floors? What kind of decisions are we going to decide off of why we're watering it? Are we just doing timed waterings? Are we going off of thresholds of VPD? Well, you know, not with a good, strong automation system, you can actually make those decisions, chart them, see your results on the plants, and you can make a lot of big decisions in the future.
Also, too, where are you getting that water from? Is that leachate water? Is that fresh water? Is that a blend? Is that, you know, if you're talking about an indoor growing environment, a lot of the times you're capturing condensate water, right? Obviously, the more water that you're able to reuse and the less that you have to take from your water source, these are all things that just go into the efficiency of a well-run automated facility, and therefore the design of a good automation system. So that's something you want to take a look at too. Not only the reasons of why you're watering, but also, you know, where are we taking that water from, and why did we choose to use that water?
Yes, and toss into that the aspect of we see branch management. You also have capacity management. So usually your facility is not set up so you can water every single plant anytime you want. You pretty much have to design what needs to get water when, who gets high priority, and how much can I water at any given time, and then have the program all calculating that for you. So you just set and forget.
You only have 24 hours in a day too. You have to think about that, right?
For some of our attendees who aren't maybe as familiar with Argus, can you just let us know a little bit about what all Argus can control?
Everything.
So mainly we do horticulture facilities, which we control the environment, complete environment. We also control the complete irrigation system, and we also control all the nutrient delivery systems.
CO2 injection too.
Yeah, CO2. Yeah. So if you want to add any gas to any of those environments, getting into like CO2, and maybe like we can go into like just a vertical farm, indoor vertical farm. And so the complexities behind a vertical farm. So people just talk about injecting CO2, which is great, and you're measuring that parameter to a certain threshold or to a certain set point, but also because of our experience, so much experience in the horticultural industry, we also know that, hey, CO2 is just one part of that. Now you have your whole irrigation system. So you also need to deliver oxygen to those roots, because you want that CO2 to oxygen exchange to get that, again, that great yield, that great quality. And we know that, hey, we can integrate with that RO system, or that dissolved oxygen system. And then we also know how to control that threshold. And we can also say, hey, if there's a problem with the valve and you have a high level of CO2, we can actually put in a purge system and alarms and all these different parameters, which when we start talking about environment and irrigation and fertigation, they all really tie together. So that's why, like Rico began with, full integration. It's so important, because there's so many aspects in a horticultural greenhouse or vertical farm that you need to have control of all these different things, because they actually affect each other. For example, again, say you have a large watering cycle inside that zone. Well, you're going to watch, and again through graphing. So your graph is nice and tight. You're holding 1 degree, and you can actually see. I can tell clients that, hey, you actually sprayed your plants or you had a watering cycle at this time, and I would check with them, and they would say, yeah, that's absolutely right. We did do that then. Especially in spray cycles, you can actually see that happening. So when those occurrences happen through irrigation, you can actually anticipate a heavy RH load and counteract that with turning on certain equipment.
Getting back to the concept of the full integration and also talking a little bit about what we do, the whole concept of fully integrated controls, which is what Argus really does, is that in an ideal world, the best Argus control systems are when Argus is in complete control of all equipment and mechanical systems that are affecting your growing environment, whether that's a greenhouse, whether that's a plant growth chamber for resource or for research purposes, whether that's an indoor vertical farm, whatever that is. And you have the full integration of all of the equipment that makes up essentially that growing space. But then the other interesting piece of that is that you also have the full integration of specific mechanical systems. So if I know Justin was talking a little bit about indoor farming and vertical farming. A really common thing you see on indoor and vertical farming is like hydronic HVAC systems. Well, you think about a hydronic HVAC system, you have to have some way of getting that chilled water and that hot water to a fan coil, right? So you want to have the macro view of this is what my chiller and boiler plant is doing and how the chilled water and hot water is actually getting to my fan coil. And then you have more of the micro view of this is what my fan coil is actually doing. These are the positions of my valves. This is the speed of my fan. This is the temperature of the water coming into the hot water coil or the chilled water coil. This is the temperature of the water leaving the hot water coil or the chilled water coil. And actually, if we go back to even a greenhouse example, macro and micro, you can do that with any kind of hydronic underbench or gutter heating or snow melt. You have the primary loop, which is the boiler. So you want to know what's going on with your hot water generation, but you also want to know what's going on at the underbench level too, right? What is the temperature of that water that's hitting the bench from the boiler? What is the temperature of that water that's already gone through the underbench system and therefore has heat loss? Can we blend that water to get to an optimum temperature?
Kind of go back a little bit. Can we talk a little about how a well-designed automation system can help you be a little bit more efficient with kind of a central access point, and then also the ability to control things remotely?
Exactly. A good system essentially knows that you don't want to spend all day long sitting in front of the computer taking a look at what's going on, and you don't want to have to go and visit each control panel in every zone taking a look at what's going on. So you want to have a way of being able to go and walk your crops, have something that's handy in your hand, whether it be your phone or a tablet or something, and being able to see what's going on in that environment, what are the temperature and humidity levels, getting a good idea of each of the areas that you're into. And once in a while, as you're doing that, you may also be checking on some equipment, making sure it's functioning properly. So having that remote ability to be able to just quickly make a test run, check, start it up, shut it down, whatever, it allows you to be able to also do quick checks and not have to just put a whole list together to check on later. So definitely that ties together the same way you're able to do that in the greenhouse. If you're not in the greenhouse, you're at home, you're at the ball game, you're at dinner. If you're running something where you're babysitting an area that you think might be having an issue, you can do so remotely without having to be stuck there the whole time. So having that remote access to view and make changes is important.
And that's a good point, Eric, because that's one of the things that we have integrated with Argus, for example, is Argus Live, kind of a web-based app. We've also got TeamViewer licensed right into our software. So we've got our system's built to have that versatility to where you don't have to be stuck at your facility 24/7. You have these alarming systems that tell you, hey, this zone's a little warm, or the RH is a little high or a little low in this zone, or actually this piece of equipment is not functioning right now. That might be through a current switch that's into the IO board, and we alarm that. So, and then all you have to do is simply either you just get your laptop TeamViewer in, or you can use your phone or your tablet with the Argus Live web app, and it keeps it very simple. I know before, when I was in the research industry, I use that quite a bit because nothing breaks at 8:30 in the morning, right? When everyone's there. it always breaks at 1:30 in the morning when you're asleep. And that ability to just quickly get on your system, see what's going on, and realize, is it a fix that needs to happen right now, or can it wait until morning? Can I turn this alarm off for right now, the high level alarm, keep a low level alarm in place just in case, or a certain threshold alarm to where if it jumps to the next threshold, it gives you another alarm, and then you realize that, hey, I need to get over to that facility right now and see what's going on and get that fixed. So yeah, the alarm system in any automation system is extremely important. The other part of that is knowing, having a lot of horticultural experience with that control system. That control system's already going to have a lot of those things in place, and you're not just recreating them all the time. So, for example, if on a vertical farm, indoor vertical farm, if you just have a regular BMS system that was really designed around just a commercial building, they're not going to know, like, well, how crucial is the temperature? They're going to have maybe big wide bands, 10 degree, 15 degree bands on alarm systems, and then alarming RH. I don't know any building controls BMS system that's alarming off of RH, unless you specifically request that, and that's custom programming. Or VPD, for example. We have VPD built into our system. That's very crucial to any horticultural crop. Well, you can alarm off of it, you can graph off of it. It's already built in. System is literally wasn't a automation system that came into the horticulture industry. It was a system built around the horticultural industry. So that's really important to know the difference between those systems.
Yep. Keeping in mind the Argus system was designed by founders who were greenhouse growers. They owned greenhouse operations. So all the design and logic on why it even came to exist was all behind automating greenhouse environments.
And regarding that remote monitoring, we do have a question here. Is the Argus system compatible with both iPhone and Android?
Yes, it's agnostic. As long as your device is able to run a web browser, you can run the remote access. In terms of the foundation program, it runs on Microsoft products. So it's a Microsoft computer for the server, but then all devices connecting to it can be on different types of devices running a browser.
Great. So, with all this monitoring, there's a lot of data. Can you talk a little bit about how people can use that data to more clearly understand what they're doing and ways to be a little bit more efficient, so maybe save some money?
I think the first step is you want to trend absolutely everything. Anything and everything that you have a sensor for, you want to be trending that constantly. And then you want to be trending that against your parameters. So in other words, meaning what are the real-time values of what's going on? What do I want to happen? And then you want to take a look at the correlations between that. And then from there, it will allow you to decide what type of a control strategy you want to take And again, when you have a fully integrated system, which would be a well-designed, automation system, you can see direct cause and effect between what it is that I'm trending, what I want it to be trending to, and how this change that I made directly affected cause and effect this desired outcome that I'm looking for. So I would say that's a big piece of it. And analyzing the data should be one of the first things I think that you do every day when you have a fully integrated system. And then you really want to take a look at it on daily trends, monthly trends, and then even seasonal trends as well. The more data you have, the better. And it allows you to make better decisions around how to optimize your strategies and the equipment and ultimately your facility. And the more that you can optimize that in a way that keeps you within your parameters, but also keeps kind of smart goals with your equipment. In other words, meaning trying to utilize equipment that costs you the least amount of money first before you go right into other pieces of equipment is going to be really crucial to a well-run system and a well-run facility.
Yeah, exactly. Like considering running stages where you have stages of cooling set up, and it takes into consideration the different pieces of cooling equipment available to work on a strategy, and when do you want them to take effect on that strategy. You may find as you're watching or analyzing your data collected that you can change some of the staging to allow for some of the less expensive, like natural ventilation type equipment to run longer before other stages of more mechanical stuff kick in. You could also use data too, which is another important aspect of reviewing your data on a daily basis and looking at the trends, is catching where the data goes outside of boundaries, being able to catch an event that's occurring that would otherwise probably go undetected until there's an obvious failure somewhere. But if you're monitoring them on a regular basis, you're going to see some deviations that you're going to maybe start paying attention to, a pump or fan or some piece of equipment that seems to be maybe contributing to it going outside of boundaries. So not having that data there, you probably won't be able to tell until it's a significant impact.
Yeah, and to add to that, on the Argus system itself, it has event timers. So it's tied to all that equipment that's in place. So it will tell you how many times it turned on and off, the duration of those times on. So talking about preventative maintenance, for example. So what you don't want is unscheduled downtimes. You want to have scheduled downtimes as much as possible. So if you've got a motor that says, hey, I run 10,000, 20,000, 30,000 hours, and all of a sudden we actually can alarm to when it meets those thresholds, it actually alarms to you saying, hey, this motor is at 10,000 hours, for example, and you should probably be thinking about replacing that. Well, then you can schedule your downtime and it's not a breakdown. And you have a new motor in there, and you can log that. And then you can reset your event timer, and that way your preventive maintenance schedule is all integrated into one system. So, and that's real important because, like Eric was saying, you're graphing and you're seeing that there's possibly some type of equipment starting to fail, maybe. Well, if you go back to your event timer and you say, well, yeah, that equipment's like 5,000 hours overdue from just replacement alone. That's where all these different aspects of one automation system can help create a consistent yield, first off. And then when you go back to the trending and graphing, so that, for example, tomatoes, you want it at this certain temperature, you want it at a certain RH, but then when you start getting into maybe research or something, and you want to say, okay, this is a different cultivar, I want to push this a few degrees this direction, I want to push this RH a few degrees this direction, and then you can graph all that, collect all this data, and you can collect it for 1, 2, 3, 4, 5 years, whatever it may be. And then you can start measuring your yields and see if you're pushing in the right direction or not. So just the ability to be able to actually document that, like we do a lot of research facilities, and they write a ton of scientific papers just off that data that's collected from that system. So again, total integration. It's very, very important.
About how predictive algorithms can help you get to your targets, efficiently using your equipment and being able to adjust your settings to get that peak efficiency?
I think when I think of predictive algorithms, one of the things that I like to think about as well are conditional controls, which is something that I think is super important and super useful when you have a flexible automation system. So the concept of a conditional control is that we have this way in which the control system is intended to operate. This is what it's supposed to do. It's going to, utilize this equipment first and then utilize this equipment second, and it's going to water at this time or do whatever the system is supposed to do. But then we have this condition, and this condition is normally tied to some type of a critical event. It could be an equipment failure. It could be power loss. Probably the most common ones that we see with conditional controls would be situations where you have like cogen systems or secondary power systems. And let's say, for example, you have a situation where you have a cogen system, and you know that the load of that cogen is not enough to handle the full lighting load of your horticultural facility. Well, as soon as that thing kicks on, your control strategy has completely changed now, because you know that you do not have enough power to kick on all of those lights, all of the equipment in that room. So you start to create a condition where you're prioritizing what is actually possible under this condition. And to me, I think that plays really well into the concept of predictive algorithms.
Yeah, being able to do load shedding, that's exactly a good point. Having a control system, an integrated control system, good high-end control system, they have abilities to integrate the load shedding for those conditions whereby you may be running on generator mode and you limp through. Need to be able to shed what you deem to be low priority equipment from high priority equipment, so you can continue to get through it and the crop has the least amount of impact during that kind of a situation.
And I think that goes back also to the flexibility of your automation system to be able to integrate with all these other systems. So if you have a very rigid control system and you want to add these sensors or be able to load shed off of a cogen system, and you have this very rigid automated control system, sometimes you lose that ability to do that. Having a good flexible system is really important, because many aspects of these different horticultural facilities want to integrate new equipment, integrate old equipment. It might be a new control system, but you might be integrating an old boom system, for example, or load shedding on lights on a generator system, to be able to take those signals in, give a signal out. Versatility on that automation system is very, very important.
Okay, so we're going to go into Q&A in just a little bit. I just want to remind everyone, if you have any questions, please use that Q&A box at the bottom of your screen. Enter your question there, and we'll get to those in just a couple of minutes. But before we do that, I did want to ask a little bit about your aftermarket services. So training, support, system audits, nutrient system training. Can you tell us a little bit about what Argus offers in terms of those services?
Yeah, so there are several different services that we've been asked for along the way that growers have found would really help them to be use their system to the powerful system that it is, to be able to use it and get the most out of it. And so one of those aspects are being able to provide training sessions, so ongoing training, training on demand as you need it. New features come along and they want to be at more ability. So we have various types of training programs available, from new user through to power user type mode, where they really want to get into the real nuts and bolts about how I can do some pretty complex algorithms, create some nice equations to do some special research or whatever. So we have various levels of training on top of other aspects for things like doing recalibration of systems. You go in and either remotely or on site or a combination of both, we can go in and do auditing of the control system, the Argus system. We can check through all of the programming, all of the sensor readings, all the equipment operations, the trend logs, check to see how things are set up, the set points that are being used, the types of equations being used, and maybe there are ways we can help them, because you can do some of this yourself when you're running your operation, and you may have added some programs or made some tweaks along the way. And then over time, you may find that things aren't quite as optimum as they could be, or you're questioning whether or not they're even as optimum as they could be. So having us go in and do a full system audit, we can recognize any areas where we might offer some suggestions to improve the way it's being controlled, or have some other aspects that you may not be aware of that would have been done that would be able to do a better control of that type of equipment or application in the greenhouse.
That's a really good point, Eric. In fact, I've gone into systems and have tuned their environmental controls and increased their yields by up to 20 to 30, sometimes 40%. So it's important to, again, always check that system, have someone has a lot of experience, not only the control system, but being able to control, knowing how to control horticultural environments, because what you thought you were having a good yield before, you might be able to tune that system and increase yields by a tremendous amount. And we've proven that again and again and again in the past.
Yeah, to that point, another piece of that would really come into various custom programming that people look for, whether it be different user screen design or implementation of a lot of the conditional controls that I was talking about earlier. And sometimes that's just because they got new things that they wanted to add to it, but all of that would be included under the aftermarket services that Argus is able to provide.
Okay, I guess we're going to move on to the attendee questions. So again, if you have any, throw them in that box, and we're going to kick it off with what are some ways Argus can take leaf temperatures into account in trying to achieve optimal VPD?
It's a great question. So that's usually done with infrared cameras. So if that infrared camera has the ability for us to take either an analog signal from that, or even a Modbus or BACnet signal, we can utilize that as essentially a sensor input and take different and therefore do different control strategies based on that. Essentially what you're doing is you're utilizing that in place of a climate sensor.
Yeah, another way to do rudimentary control, and it works fairly well, is we put a temperature sensor down over in the canopy area around the leaves. So we're measuring what the leaves are actually feeling right at that time. And with evapotranspiration, that could be different than what you're actually measuring in the climate. So we'll take that measurement and we'll take the ambient temperature and humidity measurements in the climate. And then Argus inside the algorithms will automatically derive a VPD number based on those readings. And then you can use that number to decide how you want to manage the environment for that crop, the watering for that crop, bringing the VPD level up or down to be able to maybe force the plants to start taking up more than through the roots because they maybe not taking enough, or slow them down if they're, transpiring too much, kind of thing.
Great. And can you tell us a little bit about how Argus controls irrigation booms? So can they fully control the booms, or is it just turning the controller on and off?
That would really depend. So depending on what style of boom it is, a lot of times we do just go integrate with the controller itself. So we'd be just enabling or disabling it. Because boom control can get quite complex because you have to integrate with a lot of sensors. So it's basically site specific.
Yeah, in some cases, your boom control can be, like you said, like Justin said, just a simple tell it to go and then let its controller do all of the uh, zone control of watering, what it's going to get in which zone and where the zones start and stop and so on. So that's the power of the controls on those booms. And then you'll have some simpler booms that maybe want to water left and right of the aisle separately and have some start and stop zones. So we can put that in the Argus system and then tell it, which valve, which fertigation valve, maybe you have different feeds going to the boom too, or just fresh water. So the Argus system's recipes can tell it when it wants which valve for which area as it walks along the pathway down the zone of the greenhouse.
You have to take into account too what the actual PLC on the boom will allow for as well. So, I mean, we work with a lot of different protocols. This is more common, I would say, with like HVAC equipment and chiller and boiler systems. But I mean, if we can take protocol points from it, whether it's Modbus, BACnet, or whatever, then we're just reading and writing points, and then we can get a little more integrated with whatever that controller is doing. But it all depends on what that controller allows for us to do as well, because again, usually when you have systems like that, they want to have a certain amount of control because it basically protects their equipment and therefore the warranty on that equipment. So.
Okay, next question here is for greenhouses with additive humidity capabilities. Can you talk a little bit about the benefits of using VPD versus RH when you're trying to make those humidification decisions?
Obviously, what I always go by is temperature always rules in a greenhouse. So when you take into account VPD and adding humidity, you're actually steering that RH to meet your VPD set point or demand. So because you can actually steer the wrong way if you want to compromise temperature, but drive down to a really low RH, you can actually create a VPD environment where your stem and your leaves actually close up, a very high VPD, and you're no longer transpiring. So I always go by temp first. If you want to steer off of VPD, then you are controlling that RH. Now, with a fogging system, that it's great because sometimes during the daytime you can get that really low RH. So everyone talks about dehumidifying all the time in a greenhouse, but sometimes it's the balance, whether it be, and this goes back to also even in a vertical farm, indoors. You want to keep that a type parameter or type VPD. Well, in order to do that, you have to have good temperature control if possible. But then even if you're in a greenhouse and you maybe have to steer a little high, you want to be able to.
So,
RH to a certain point.
So just to piggyback off of Justin's point, understanding that relationship between temperature, relative humidity, and then also VPD is super important. I think there's definitely a crop element to it as well because, let's say you're growing a crop like, for example, orchids, and you want a really humid environment, you may utilize, obviously temperature is going to be super important, but you may choose to have a little bit higher of a relative humidity based on the crop that you're trying to grow as well.
Okay, and can Argus be used to calculate growing degree days both for indoor and outdoor growing environments?
Yes. Short answer, yes. Yeah, Argus developed grower degree day type algorithms quite a few years ago to be able to optimize the requirements for meeting the heating and cooling loads. So knowing what your plant can use, what the total load it needs, it's possible that you could get by with being able to cut back your set point by a couple of degrees or a few degrees even, if it seems to have received enough of the heat load that it can get by for a couple of days at cooler loads. So having a system that automatically calculates that and then figures out what those are, it makes your job a lot easier, because now you don't need to worry about, how much can I set it back by? How long can I set it for? Remembering to set it back when I need to, before it gets too far the other way. So having the system automatically do that is great. Yeah, that's one of the powers of being able to economize on your equipment operation and still have your plants receive what they need.
Great. And someone here is asking if they can have some more details on nutrient analysis. So what sensors are being used to analyze that, in the soil, in the plant, um, just kind of how does that work?
So we do have Argus itself has a nutrient delivery system where we use redundant pH sensors and EC sensors. But to add to that, we also integrate in with a lot of inline EC sensors and pH sensors. So you might be delivering a batch water out of a batch tank that's already been infused with nutrients, and you want to measure what that EC and pH is in that batch tank, but maybe you want to know exactly what is getting delivered at the table. We can also integrate with those sensors. So if what your batch tank is saying, and that's your target that you absolutely want, but then it goes down a really long corridor. Say we're a really large greenhouse and it's a very hot sunny day and the pipes are exposed, and your delivery at the tables has a different pH, for example. You can actually stop that watering cycle if it gets out of a certain parameter, and that way you can ensure the delivery to your crop is exactly what you want it to be.
So that goes back to well-designed too. Having a well-designed irrigation system can kind of mitigate some of the issues you might run into with having really long lines that may have impact through solar gain or whatever, that, what you're going to get at the crop may be too hot, might be the wrong recipe. So having sensors in the right locations, possibly might have to do batch tanks to create more of a isolated areas where the recipes already exist to stop them from having to do such a long travel. Being able to measure those tanks on a constant basis and know what's in them, change the recipes as required, measuring my BC, temperature, pH, total dissolved solids. Pretty much anything that you can connect to a control system, Argus can interface.
And so if someone were to decide to make the switch from their existing control system to Argus control systems, can you tell us a little about what that would look like and what all would need to be replaced if someone decided to do that?
Good point.
It's a really great question. And a lot of it is going to come down to your electrical infrastructure. So your contactors, your relays, your breakers, all that kind of stuff. So depending on really what it is, the vast majority of the time, what we're really replacing are the controllers and the control signals or the low voltage IOs. So as long as your contactors and your relays and breakers and all of that is already in place and still well intact, we would be able to plug into that just like any other control system. So, and we're very flexible on how a customer wants to go about that. They may choose to do it in sections, and sometimes those sections are broken down by, well, first I want to, replace replace my control system with Argus, but I want, my most critical need right now is my irrigation, fertigation, and water processing. So I'm going to take that whole system now, and that's going to be Argus. Or sometimes they do it on a zone by zone basis. So we're very flexible with any ways that a customer would be interested in integrating our technology.
Okay, and last question of the day. Can you give us some more information on your training programs? Are they online? Are they in person? Where can folks request that? And where can they find a schedule, if that's available?
Okay. Probably easiest way to answer that is they aren't online. When they used to be online was prior to COVID days, and we used to be able to have training sessions all over. So what we do now is we invite anybody who's interested in information or getting some timing for training or so on, or even getting more information about what we have to offer. Simply just sending an email into sales@argoscontrols.com is the easiest way to get whatever you need for information.
Okay, sounds good. Well, thank you all. Thank you, Justin, Eric, Rico, for joining us. Thanks to everyone who attended. Like I said, there will be a recording of this going out in the next couple of days, so look for that in your inbox. And thank you so much, everyone.